Okay, folks, welcome back. Quadratic functions and equations, lesson 4. Equations and intercepts from the vertex and a point. So we've learned how we can manipulate our standard form of our equation and how we can determine what those different parameters, how they affect our parabolic curve. Now, if we're given some information, we should be able to create an equation. So basically, the steps are kind of laid out here. But let's go through it. Determining the equation from the vertex and a point. Following procedure will allow us to enable to write quadratic functions in standard form if we're given the coordinates of the vertex and another point on the parabola. If we're given the coordinates, we know that we're given the coordinates in the form of xy, and we know that that is PQ in our standard form equation. So we can substitute that straight into our standard form equation. If we have a different xy point, so I'm going to call it x1, y1, so a different point, we can substitute those values in for x and y, and that's going to leave us the only variable left, and that's a. So then we solve for a, and then we can rewrite our equation using a that we just found and p and q that are given to us. So let's look at example 1. Graph of the quadratic function has a vertex -2 and 8 and passes through the point -1, 7. Find the equation of the function in standard form. So we know our vertex is -2, 8. So I can simply start by saying, well, y is equal to a bracket x minus -2 squared plus 8. Make sure I get it right, -2, 8. I'm going to simplify this a little bit. I don't like the minus minus. Y is equal to a bracket x plus 2 squared plus 8. Now our other coordinate point was -1, 7, -1, 7, and we simply substitute that in for x and y. And when we do that, you'll see 7 is equal to a bracket -1, I'll put that in its own little bracket, plus 2 squared plus 8. You can see we only have one variable. And like I've said many times this year so far, if we have any equation with one variable, it is solvable. So now we just work out, we do the math, and we figure out what a is. So I'm going to simplify that squared bracket first. I'm going to get 7 is equal to a bracket -1 plus 2 is 1. 1 squared is 1. So this becomes 1 squared, or 1. I'm going to put the squared in, just as an extra intermediate step. Well, 1 squared is 1, so a times 1 is 1. So this is just 7 is equal to a plus 8. To get a by itself, I do the opposite function. I subtract 8 from both sides. -1 is equal to a. Now that I have a, I can simply rewrite my equation. Y is equal to -1, which is my a, yeah. And then x minus p, which was minus the -2, so that's plus 2, squared plus 8. And that would be complete. The graph over here, I think is for question C, using a graphic. Yeah, so question B, rewrite the equation in general form. So now this is what we have. Y is equal to -1 bracket x plus 2 squared plus 8. And we want that in the form of ax squared plus by plus c equals 0. So really, we have to expand those brackets, bomb that -1 in, and then combine some like terms. So I'm going to tell you, you should probably always get into the habit, and I know I've said it before, x plus 2 squared means x plus 2 times x plus 2. If you're going to go wrong, chances are that's exactly where it's going to happen. So expand that, then do your bombing. And I know that this is FOIL. So first, outside, inside, last. Y is equal to -1 times x squared plus 2x plus 2x plus 4 plus 8. Bomb in the -1. Y is equal to -x squared minus 2x minus 2x minus 4 plus 8. Combine your like terms. -x squared minus 4x My plus 8, negative 4 plus 8 is, sorry, not 8, 4. 4. That is your expanded form, general form. Now we answer our last question. Question D says using a graphing calculator to sketch and graph, determine x and y intercepts of the graph of the function, and round answers to the nearest hundredth if necessary. So I already know what the y-intercept is. Remember, in general form, our y-intercept is this constant at the end. So positive 4. So I can say my y-intercept is 4. The other ones, I am going to use Desmos. I am going to use my graphing calculator or whatever functions necessary. And I'm going to put this equation into Desmos as soon as Desmos loads. Anytime, come on, there we go. Y equals negative 1 bracket x plus 2 bracket squared plus 4. And you can see your x-intercepts are negative 4. Ooh. Ooh, there's something wrong here. Give me a moment. I figured it out. I put the wrong equation in here. This should be an 8. That's better. So we can see our vertex is negative 2, 8. And I can see my x-intercepts, or sorry, my y-intercept is 4, just like we've said already. And my x-intercepts are negative 4.83 and 0.83, because it says to round to the nearest hundredth. Going back to our notes, my x-intercepts, oops, I don't know what happened there. My x-intercepts, negative 4.83 and 0.83. And you'd be complete. And I think now we just get to play with all of that information a little bit more. So over the page, finding intercepts from standard form. We can use the equation of the quadratic function in standard form to algebraically determine the x and y intercepts of the graph of the function. To do that, we start with, you choose one, x or y intercept, it doesn't really matter. But we do know that when we have our intercepts, so here's our coordinate grid, points that cross the y-axis will always have a 0 value for x. Points that cross the x-axis will always have a 0 value for y. Okay, so you can substitute those values in to find the missing ones. So I'm going to start with my y-intercept. I know that x is equal to 0. So I substitute that into my function. So f of x, remember, is just y. So y is equal to 3 bracket 0 minus 1 bracket squared minus 9. 0 minus 1 is negative 1 squared minus 9. Negative 1 squared is 1 minus 9. Negative 1 times 3 is 3. Minus 9 is negative 6. Now we do the same process, except this time we're looking for our x-intercept. We make y equal to 0. So this is going to be 0 is equal to 3 bracket x minus 1 squared minus 9. I need this term by itself, so I need to get rid of the 9. So I'm going to add 9 to both sides. That gives me 9 is equal to 3 bracket x minus 1 squared. Before I square root, I need to get rid of the 3, so I'm going to divide by 3. Divide by 3. 3 is equal to x minus 1 squared. And to get the x minus 1 by itself, I square root this. So I square root the other side, and in square rooting the other side, remember you get a plus and a minus version. So now I have plus or minus the square root of 3 is equal to x minus 1. To get rid of that 1, I add 1, add 1. So now I have 1 plus or minus the square root of 3 is equal to x. That gives us two values, our two x-intercepts. So I'm going to go 1 plus square root 3. That's one of them. The other one is 1 minus square root 3. You can leave those as exact values unless the question specifies decimal points. Okay, so there's your two x-intercepts. Example number 3. The graph of the quadratic function is shown. The maximum point is shown. Find the equation of the function in standard form. Well, look at that. We have our vertex. We have a point. So just like before, we can do this. We take our standard form equation. Y is equal to a bracket x minus p squared plus q. We're going to substitute in our p and q. A bracket x, what is it, negative 1 minus 1 squared plus 2. Y is equal to a bracket x plus 1 squared plus 2. And now we substitute our other point because it gave you another point, negative 3 and 1. Negative 3 and 1. So this is negative 3 is equal to a bracket 1 plus 1 squared plus 2. Negative 3 equals a. 1 plus 1 is 2 squared plus 2. Negative 3. 2 times 2 is 4, so 4a plus 2. Now solve for a. Subtract 2 from both sides. That's negative 5 is equal to 4a. Divide by 4. So a is equal to negative 5 over 4. Now you can rewrite your equation using a, negative 5 over 4, bracket x, plus 1 squared plus 2. Find algebraically the x-intercepts and the y-intercept of the graph. So you can go through the work for the x-intercept and y-intercept by substituting in your zeros. To find the y-intercept, you could also expand this into general form and find your y-intercept. Whichever process works best for you, it makes no difference to me, okay? As long as you come up with the right answer. So let's do our y-intercept first. That means x is equal to 0. I'm going to take the equation that we just developed. Y is equal to negative 5 over 4 bracket x plus 1 squared plus 2. Just double check, make sure that's correct. Looks right to me. And I'm going to substitute in a 0 for x. Negative 5 over 4, 0 plus 1 squared plus 2, 0 plus 1. 0 plus 1 is 1, 1 squared is 1. So this is just negative 5 over 4 plus 2. Remember, if you're adding fractions, you need a common denominator. This is over 1. So this becomes negative 5 over 4 plus 8 over 4. Adding across the top gives us 3 over 4. 3 over 4 would be your intercept. 3 over 4 would be your y-intercept had I done the math prior to this correctly. So I'm hoping that you were all screaming and wondering when I was going to make that correction. And I wish I knew how to edit my videos, but I don't. But I completely botched this step. This is negative 3, 1. That's xy. And I substituted x for y and y for x. So this is completely wrong. So we're going to back this video up, make it a little bit longer. Sorry, Jonah. Make it a little bit longer so that we can fix this. So I need to erase all of this. And then we're going to start this process again. So because we had this wrong, this below is also going to be wrong. So I'm going to erase this too. My bad. So going back here, substituting correctly now this time. 1 is y. A we're looking for. X is negative 3 plus 1 plus 2 squared. 1 is equal to a. Negative 3 plus 1 is negative 2 squared plus 2. Negative 2 squared is 4. 1 equals 4a plus 2. I'm going to subtract 2 from both sides. That's negative 1 is equal to 4a. And I'm going to divide both sides by 4. So a is equal to negative 1 over 4, which changes our equation significantly. Y equals negative 1 over 4, bracket x plus 1 squared plus 2. There's your equation. Follow the same step. Now we're going to find our x-intercept. We're going to make our y-intercept. We're going to make x equal to 0. Substitute that into our formula. 0 plus 1 squared plus 2. 0 plus 1 is 1. Negative 1 over 4. 1 squared plus 2. 1 times 1 is 1. So this is y is equal to negative 1 over 4 plus 2. Still needing our common denominator. So I need a common denominator of 4. Negative 1 over 4 plus 8 over 4 leaves 7 over 4. That's your y-intercept. As a decimal, sometimes it will ask you, you would just divide that. 1.75. And then we do our x-intercepts. So our x-intercepts, we make y equal to 0. We take our equation, equals negative 1 over 4, bracket x plus 1 squared plus 2. And now we solve for x. So we made y equal to 0, and now we're solving for x. I'm going to subtract 2 from both sides. That gives me negative 2 is equal to negative 1 over 4, x plus 1 squared. I'm going to divide by negative 1 over 4, divide by negative 1 over 4, and then really quickly remember over here, 2. So we are dividing negative 2 by negative 1 over 4. So it's negative 2 divided by negative 1 over 4 is negative 2 times negative 4 over 1. Negative 2 times negative 4 is negative 8. So this now becomes negative 8. X plus 1 squared. Not negative 8, sorry. Negative times a negative is positive. Positive 8. So I'm not even going to write that in there. It's positive 8. And of course, this is in brackets. We're going to carry on over here. I'm just going to rewrite it. 8 is equal to x plus 1 squared. I'm going to square root both sides. Remember, that gives you the plus or minus square root version, equals x plus 1. And I'm going to subtract 1. Negative 1 plus or minus the square root of 8 is equal to x. And again, just like always, just like before, we need to simplify this radical, which hopefully you remember is 2 root 2. Oops, not so plus, that's equals. Now, questions might ask for exact answers. You'd leave your answer right there. That's totally acceptable. Otherwise, you may have to calculate the decimal places. So I'm going to take a negative 1 minus 2 root 2. And then I'm going to do a negative 1 plus 2 root 2. And then those would work out to their individual decimals. I have negative 3.83 and positive 1.83. Okay, double check, you make sure you can get both of those. State the domain, the range, and the equation of the axis of symmetry. Well, the domain is always the same. X belongs to the set of all real numbers. My range, y, now I need to look at my parabola. Is this parabola going to be opening up or down? This parabola opens down, so it's going to have a maximum right at that value there of 2. So this is, because it opens down, has to be less than equal to 2. You can see other forms of this being written. There's just a bit more detail in those forms. This is totally fine and acceptable for me. Okay? So your workbook might show you a different form. The equation of the x-axis of symmetry, because it is an equation, always has to start with x equals, and it's the x value of the vertex, -1. Because this line, so that line tells us our range. This line tells us our equation of the axis of symmetry. That's x equals. Takes us to the end of lesson 4. Doing some questions. My guess is probably all of them. Why not? And checking Stellantis for any changes. And we'll see you next time.